Hello everyone, my name is Mohammed Ali Gulzar, and today I'll be demonstrating our tool BigSift. When big data analytics jobs produce outliers or errors, it is really hard for the developers to figure out what is the root cause of the problem. This task is challenging mainly because of the sheer size of the input dataset and also because of the series of transformations that are being applied on the input dataset, making it really hard for the user to figure out the mapping between the output and the input. Our tool BigSift is a cloud debugger that finds the minimum set of fault-inducing inputs by combining insights from delta debugging and data provenance, along with a series of systems optimizations, making automated debugging a reality for big data analytics. BigSift takes in the Spark program, a test function, and the input data, and then it applies data provenance and delta debugging along with a series of transformations like test predicate pushdown, prioritizing backward traces, and bitmap-based test memoization to produce the minimum set of fault-reducing input records. In this demonstration, we'll be using the following motivating scenario where the input data set contains passenger transit information. We have the date, the passenger ID, arrival time of the passenger, departure time of the passenger, and the airport code. And our goal is to find out the total layover time of all the passengers spanning less than 45 minutes per airport at each hour. The output that we get seems suspicious because of the negative values of the total transit time. So we implement the motivating scenario in the following Spark application where we first apply the map operation to extract the key and the value. Then we filter out all the passengers spending more than 45 minutes as transit time. And eventually we sum up all the transit time for all the passengers in one key group. Now we will move on to the IDE to figure out how we can enable BigSift onto a Spark application. So I've already wrote my running example in this method called program. And we'll write this whole running example using the normal Spark template program. So we start off by writing the Spark context, and then we will call this BigSift API by giving it the Spark context and the input data file. And then we can just call run with BigSift method by giving it the output type of this program and the actual program that we have written in this method. So now we'll run this program and go to the UI to automatically debug this program. BigSift UI is available on port 8989 of the driver node. So we can go to this page, and here you can see the input data size, which is around 9 million records. The first job that was run was actually the original job, and it took 21 seconds to run that job. And then the user can actually inspect the output in this text box to see what are the outlier records. Furthermore, BigSift also provides this visual UI that actually visually represents the key value pairs that are represented here as well. For example, in this case, it says that the value for Seattle is something which is abnormal, and it marks this record as red. So by visually inspecting this output, a user can figure out what are the output values that he or she wants to debug. BigSift provides a list of predefined test functions that the user can use to explain the outlier values. For example, the first option, it helps identify the input records that actually led to the minimum output value. But in this case, we're going to use the last option that actually allows us to write it like the user-defined test function in this code box here. So we're going to write the test function to identify what are the input records that lead to the negative value in the output. So once we are done writing the test function in the code box, we will press this Run BigSift button to identify what are the input values that led to the output values, resulting in a test failure. So as you can see here, the process has been started, and the initial size of the fault-reducing inputs were around 9 million records, and then the first step that BigSift performs is data provenance, drops down the size or the scope of the fault-reducing input records to around 600,000 records. At the same time, you can also view the sample of the input, the fault-inducing input in this table. Furthermore, to visualize the data provenance that was done in this first step, BigSift provides this visualization of the workflow that actually tells the user how much did each partition or each transformation contributed towards the faulty inputs. As you can see here, the reduced by key in stage 2 actually contributed around 10%, and 10% of the records were actually faulty. So after around 200 seconds, BigSift was able to find the precise record that was responsible for producing a negative output value that was under investigation. So this was the record that was actually responsible for creating that value. And in the program, we were actually
the program is actually not capable of handling the departure times that are actually on the next day of the arrival time. So this is something that needs to be fixed in the program so that this problem does not occur anymore. And you can also see the notification being shown to the user that the debugging time took around 224 seconds. So this is the end of the demonstration, and thank you so much for watching.